Okay, here's what I want you to consider. Look at this from Ro's perspective, right? Ro is going to look at this and say, okay, there's no pure solution. If I play R1, then if column plays C1, I'm going to gain 1, but if column plays C2, I'm going to lose 1. If I play R2, column plays C1, I'm going to lose 1. If column plays C2, I'm going to gain 1. But notice if Ro decides to use a chance device, a coin say, and just simply flip it before every single play. Heads go R1, tails go R2. Ro would then be playing a following mixed strategy. 1/2 a chance of playing R1, 1/2 a chance of playing R2. Suppose column adopted exactly the same strategy. Throw a coin, heads, play column 1, tails, play column 2. Column would be playing the following mixed strategy. 1/2 chance of playing C1, 1/2 chance of playing C2. Now calculate the EU of this game now for Ro under these strategies. 1 of 4 times, that is half the time that column chooses R1 and half the time that column chooses C1 and Ro chooses R1, 1/4 of the time in this game, Ro is going to end up +1. 1/4 of the time, when Ro chooses R1 and column chooses C2, Ro's going to end up at -1. 1/4 of the time, where Ro chooses R2 based on the coin flip and column chooses C1, Ro's going to lose 1. And another 1/4 of the time, when the coin chooses R2 for Ro and the coin chooses C2 for column, Ro's going to gain 1. And if we calculate this out, we'll get 1/4 minus 1/4 plus, minus 1/4 plus 1/4. And if we do the same thing, the EU for column, we'll get exactly the same thing and discover that if each of them plays their part of this mixed strategy, they can have an expected utility of this particular game, both of them equal to 0. That will be the expected payoff over a number of plays if Ro plays that strategy and column plays that strategy. And notice something else. If either of them diverge from playing this strategy, if column decides, for example, to just simply play C1 with a probability of 1, Ro can now exploit column's irrationality by just simply playing R1 on every play. If column decides to play 3/4 C1, 1/4 C2, Ro can exploit that by also playing R1 all the time, right? In order to win 3 out of every 4 times and only lose 1 out of every 4 times. So as you see, if both of them play their part of this particular mixed strategy, they both will wind up with the highest expected monetary value that they can, expected utility value that they can in this game. Therefore, this particular mixed strategy on Ro's and column's point is in equilibrium. If they hit upon this particular combination of strategies, neither of them will have any reason to unilaterally change his or her strategy, because the other one could then exploit his or her mistaken choice.